Good morning, guys. In this video, we will see projection of solids, how to get the projection for a solid object. So first, we will see some of these topics in the projection of solid, and then we will see how to draw the projection in the AutoCAD software. So, a solid is a three-dimensional object having length, breadth, and height. Okay. So here we are going to do the orthographic projections by placing the object in the first quadrant, it means first angle of projection, and then we are going to get the front top views. Okay. So if it is a front view, we will represent the length and height of the object. If it is a top view, we will represent the length and the breadth of the object. Okay. So there are some shapes. So we will use to draw this solid shapes. We will use to draw the projections. It is classified majorly into two types. One is polyhedra and another one is solid of revolution. Okay. Under polyhedra, we will have three different subgroups. Okay. One is this regular polyhedra, which consists of this tetrahedron, hexahedron, and next is prism. Prism is nothing but is having a similar kind of top and bottom faces, that is having a plane figure at top and bottom, and both the top and bottom are connected using a rectangular face. Okay, then we call it as a prism. So these are some of the examples of this prism objects: this triangular prism, square prism, rectangular prism, pentagonal and hexagonal and octagonal prisms. And there is one more, which call it as pyramid. So pyramid is having only having a plane figure at the bottom, and from all the corners it is connected to a common point called apex. So here pyramid is will have the triangular faces. In case of prism, we have seen rectangular faces, whereas in case of pyramid, it is a triangular face. So here it is. Here the examples are triangle pyramid, square pyramid, rectangular, pentagonal, hexagon, and octagonal pyramids. So then the second type is solid of revolution. It is generated by rotating this plane surface about one of its edge. So here these examples are cylinder, cone, and sphere. Okay, for these objects we are going to see the projections. So before seeing the projections, in the projection of solids, we are having six different conditions for placing the solids in the plane. So here these are the six conditions: axis parallel to VP, perpendicular to HP. The axis of the solid perpendicular to VP, parallel to HP. Axis parallel to both VP and HP. Axis perpendicular to VP and inclined to HP. And the axis inclined to VP and perpendicular to HP. And the final case is axis inclined to both VP and HP. Okay, in this video we will solve some. We will draw the projections for some 5 or 6 problems. Based on the condition 1, axis parallel to VP and perpendicular to HP. Sorry, based on the condition yes, based on the condition 1, we will see some few problems how to draw the projections in the AutoCAD software. Okay, so take the first one: a square pyramid or prism of base side 30 mm and axis length 60 mm is resting on HP on its base. Okay, with the side of base inclined at 30 degree to VP, draw its projection. Okay, now as we'll consider it as a prism, a square prism. As a square prism is resting on its base on HP. Okay, that means the axis of the prism is perpendicular to HP. According to the condition given, the axis is perpendicular to HP and parallel to VP. So whenever we have drawing the projections, first we have to identify on which plane we are getting the true shape. Okay, we have to start from the true shape and then we have to project the projected front and top view. Okay, so according to the condition given, so the axis is perpendicular to HP. Okay. So when the axis is perpendicular to HP, the true shape will fall on the HP, that means horizontal plane. So here we are going to draw the square, but they have given one more condition, that the side of the base of square is inclined at 30 degree to VP. Okay. So now we'll go into the software. The 3 basic settings. So we'll do that. Set the units, set it in millimeters. It's already in millimeters. And the limits, so limit is the we have to define the boundary for our workspace. Okay, so here I'm putting 0 comma 0 and 420 comma 297, which is the size of a A3 sheet. Okay. And then zoom. Okay, zoom command is very important. Now take a line and put a reference line. So this is for a random length. I'm taking it for some 200. Now give the names text, click the start point and specify the text height 5, angle of rotation 0. Now this is X and this is Y. Above the plane it is VP, below the plane it is HP. Okay. So now according to the condition given, we will get the true shape on the horizontal plane. So we have to draw the square in such a way that one of the sides should be inclined at 30 degree to VP. If it is 30 degree to VP, we have to mark that angle on HP, because this 30 degree to VP, any inclination with respect to VP, you can able to see that inclination when you see from the top. Okay, so top view will always come on the horizontal plane. So we have to mark the 30 degree on the horizontal plane. Okay, take a line. So switch off this F8 so that you can get an inclination line. So put an inclined line for 30 degree. So the length of this line is, you can take it randomly. So I'm taking it approximately by moving the cursor, mouse cursor, and then I'm going to define the angle. So the angle should be this, the other side of this angle should be this 30 degree. Okay, so now this, it is showing 130. Okay, this side should be 180 minus 30, that means 150. I have to get this side. So if I go and check the angle, so take angular dimension, and the angle between these two lines should be 30 degree. Yeah, see, it is 30 degree. Now we have to place the square in such a way that one side of the square should align with this inclined line. Okay, so for that, so I'm typing polygon. So number of sides 4. So select the edge method. Polygon. Number of sides 4. Enter. Select edge method and select the one of the corners on the line. Okay, and come down like this. Press F8 so that you will get a straight square. So now the side length is 30 mm. Specify 30 mm. Okay. Now what we have to do? Now we have to rotate the square by. So what is this angle? We have to know this angle, and we have to rotate the square. So this angle should be this. So we will measure this angle. So this angle is 60 degree. Okay, we have to rotate this square by 60 degree. Okay. So I'm deleting this angle now. So now select this square, click on the rotate option and select this one as base point, and you have to rotate it by 60 degree. But see the center of the cursor, it is showing that if you give a positive value, it will go in anti-clockwise direction. So for me, I want to rotate the square in clockwise direction by 60 degree. So I am going to give minus 60. So now the square is exactly aligned with that inclined. Okay, now you name the corners. So again use the text option, text, start point. So I'm going to give this A dash. So for representing the top view, you put a dash over this alphabet. So this is B dash, C dash, and D dash. Okay. Now this is the true shape of the square according to the now we have drawn the true shape of the square according to the question given, according to the condition given in the question. So now take line to get the top view. Sorry, this is the top view. To get the front view, So front view, here we are taking this as a prism. So in the front view, you will get a rectangular faces. So first project vertical lines from all the corners up to this reference line. So after projecting this lines, vertical lines from all the corners, now we will draw the this prism face on the front view, because you are going to get those can see those rectangular faces when you see from the front. So take a line, start from here. So the length of this axis is given as 60 mm, so you have to mark 60 mm this vertical line, and then from every projected lines you mark a vertical line for 60 mm. Now take a line and connect all the end point of this, the lines that we drawn on the VP. So now, so this is the this is the front view. So now we have to mark the axis. So before marking the axis, we have to find out the hidden edge. Okay. So when you see from the front, okay, you are standing, and when you see from the front, you can able to see only the edge A, B and C edge. You can able to see this D edge comes on the back side of this object, which is an hidden one. So if it is an hidden edge, you have to mention it in dash lines. So you can change the type of the line here. So generally we will use continuous line. So if you want other kind of lines like dash lines for mentioning the hidden edges, and then center line for mentioning the axis, so go here, load. So you take this first one, dash, and there are some lines for center also, mentioning the center also. So I'm going to select, there are three types of center lines, so I'm going to select all the three. Press Ctrl to select multiple objects. Okay, click OK. So now you see all this parameter are loaded here, all this type of lines are loaded here. Click OK. Now the edge D is a hidden edge, so I'm selecting this line and going to change it as a dashed one. Okay, this, as it is a hidden edge, we have to mention it in dash type, and then you have to mention the axis of the prism also. The axis is the line passing through the center of the object. So take a line from the center, you connect a line to this, and again extend a line to the prism length. Now you change the type of the center line to a center type. So now we have to give the namings. Okay, so to highlight the corners, so okay, so this is top face. Okay, this is top face. Okay, so you give the namings. So this is A, B, D, and then C. Okay, this is top face. Okay, there is if it is a prism, it is having a similar kind of face at the bottom also. You have to give the name for the bottom also. This P, Q. You take this as S and this as R. So now this hidden face corners you have to mention on the top view also. So go here, click on this alphabet A dash. So within the bracket you mention P dash. So this is to represent the bottom face corner. So when you see from the top you can't able to see these corners, so that's why we are mentioning it in the brackets. Okay. Okay, now after completing the projection, define the length, the axis length as well as the side length. So for side length, here the square is aligned in 30-degree angle. So take align dimension, specify the okay. This is the projection for the question given. So after completing, so you have to write all dimensions are in mm at the bottom. Now, so this is we have taken this as pyramid, the prism, and then drawn the projections. Now we consider it as a square pyramid. So if it is a square pyramid, instead of this rectangular faces at the front view, you have to draw the triangular faces. You have to put a triangle instead of a rectangle. So we will see that also. So I'm going to extend this line. So I'm going to draw the projection for a square pyramid for the given condition. So okay, again first take a line. So this angle is 180 minus, sorry, this length is for random, you take it randomly. Press tab and then give 150. Okay, now we have to place the square here. So type polygon, enter number of sides as 4, select edge method, select start point on this inclined line, press F8 and come down and specify 30 mm. Now we have to rotate this one, so select, click rotate. You have to rotate about this point, you have to rotate it by 60 degree in the clockwise direction, give minus 60. So now rotate. Now you have to name the corners. So again type text, start point, so A dash, B dash, C dash and D dash. So since it is a pyramid, what we have to do, when you see from the top, we have to connect this all the corners to the center of this base plane figure. Okay, this is only for a pyramid. You have to connect a line from the corner of the given shape to the center of that shape. Okay. This center you name it as O dash. Now to get the top view, sorry, front view, so project vertical lines up to this reference line. Now from the center also you put a line, okay, this axis line. So whenever you are dealing with a pyramid, the first while marking the axis length, you have to mark from the center line. Okay, you have to mark from the center line. Whereas in case of prism, you can take any side and you can mark this axis length. But in case of pyramid, you have to take the center line and you have to mark the axis length. So the axis length is 60 mm. Okay, from the center line, you take 60. Okay, next, what you have to do, from all the corners, you have to connect to this common point. Call it as this one as apex point. So when you see from the front, okay, this line is the hidden line. So you have to mention it in dash types. And this one is the axis line. Use the center line option. So now you have to mention the alphabets. Okay. Type text. So this is O and this is A, B, this D and this one is. So now we have to give the mention the length, this axis 60 mm and also the length of the side on the top view. Okay, so take align. And also give this angular dimension. Okay, this is the projection according to the question 1. So we have drawn for both prism as well as the pyramid. Now I'm going to save it in PDF. So you have to select the things which you want to take print out. I'm selecting all this. Now select the center of the plot, landscape, check the preview. Now it is fine. Now save it. Of solids. Okay. Condition 1. Okay. Yes. Axis perpendicular to HP. So I will attach this PDF in my personal website. I will share the link to my website in the description box. If you want, you can download it. Thank you. So for the remaining questions, there are 4 more questions. The remaining questions I will put it in a separate video, the next video. Thank you.